This video discusses vertical asymptotes. The line x equals a is a vertical asymptote for the graph of a function if f of x approaches infinity or negative infinity as x approaches a from either side. In these four pictures, I have our asymptote is our dotted red line, and the graph of our function is there in blue. It's a vertical asymptote when your graph either points basically straight up or straight down on either side of the asymptote. Now, technically, our graph would not be going straight up or straight down. It's not a vertical line. It is getting closer and closer to the asymptote. It's just so small it's hard to see. It makes it look like it's a vertical line. So as x approaches a from the right, f of x approaches positive infinity in our first picture. Then as x approaches a from the left, f of x approaches positive infinity. In our third picture, as x approaches a from the right, f of x approaches negative infinity. And lastly, as x approaches a from the left, f of x approaches negative infinity. Vertical asymptotes can never be crossed, and a rational function may have 0, 1, or several vertical asymptotes. If a rational function has a common factor in its numerator and its denominator, then a hole exists in the graph of the function at the 0 of the common factor. So what do I mean by a hole? I mean just that. The graph's going to be going along, and then all of a sudden there's going to be a hole, and then it's going to keep going in the same direction that it was. So how do we locate vertical asymptotes? To locate vertical asymptotes and holes, we're going to start by factoring both the numerator and denominator of the rational function. We're actually going to look for holes first. If there is a common factor, a hole exists at the 0 of that factor. You're going to simplify the rational function by canceling the common factor, and then make a note that there's a hole at the 0 of that factor. Then we'll look for vertical asymptotes. Vertical asymptotes exist at the zeros of the simplified denominator. Let's locate any holes or vertical asymptotes for each of the given rational functions. First up, we have f of x equals 3x minus 1 over 2x squared minus x minus 15. We'll start by factoring both the numerator and the denominator. The numerator does not factor. I like to put parentheses around it though, because it reminds me that I can either cancel that whole factor or no part of it at all. The denominator factors into 2x plus 5 times x minus 3. Now we look for a common factor. There is not a common factor between the numerator and denominator, therefore, there's no hole. The vertical asymptotes, we find those by finding the zeros of our simplified denominator. Now this one didn't simplify, so our simplified denominator is just the same as our original denominator. So to find the vertical asymptotes, we just set the factors in the denominator equal to 0 and solve. We get x to be equal to negative 5 halves and x to be equal to 3. It's really important that when you write your vertical asymptotes, you write x equals for each one of them. We are writing equations of lines here Therefore, we need x equals in front of both of them. It is not correct to say that you have vertical asymptotes at x equals -5/2, comma 3, as if you're listing a bunch of numbers. Don't do that. We have vertical asymptotes at x equals -5/2 and x equals 3. Let's try another one. G of x equals x squared minus 4x over x squared minus 7x plus 12. The first thing we want to do is factor the numerator and denominator. GCF of x in the numerator. Denominator factors nicely. X minus 3 times x minus 4. Next, we look for a common factor. In this example, we do have a common factor. We want to simplify the rational function by canceling that common factor. So we're left with g of x equals x over x minus 3. But since there was a common factor, that tells us that there's going to be a hole in our graph at the 0 of that common factor. We're going to have a hole at x equals 4. Now we turn our attention to identifying vertical asymptotes. Vertical asymptotes exist at the zeros of our simplified denominator. Our rational function did simplify this time, so our simplified denominator is x minus 3. The vertical asymptote exists at the 0 of that factor. Therefore, we have a vertical asymptote at x equals 3 and a hole at x equals 4.